So today we're looking at how to solve a classic pulley problem. And of course, we're going to start with the place where I always recommend you to start, and that is we're going to draw a free body diagram of each object here. So we have a person on the left-hand side of the pulley, and we have a barrel on the right-hand side of the pulley. I always say, first thing in your free body diagram, draw the force of gravity. Almost guaranteed to be a force of gravity acting on each object. I'm actually going to write FGP here, and for the barrel, I will write FGB because if we put them in the same equation, we don't want to get them confused with one another. So step number 2 of drawing a free body diagram is look at where there are contact points between the object and some other object. So right here, the person's hands contact the rope, and right here, the rope contacts, this is supposed to be a 500-kilogram barrel of bricks. So those are the only 2 contact points. At this point, by the way, the person has been lifted off the ground, so they're not touching the ground. The reason that contact points are so important is because except for the force of gravity, that's where every other force is going to come from. Every place there's a contact point, there's a force. So where the person's hands contact the rope is going to pull up on the person. Now we can call that a tension force, and it is a tension force. If you're not sure why it pulls up, think about a rope. There's no way you can push with a rope. You try to push with a rope and it goes limp. So this has to be a pulling force here. Same thing for the barrel. Right at this location, the rope touches the barrel. So there's a tension force there. It's a contact point. There's going to be a tension force. Now, should I label these with a different subscript so we don't get them confused? Well, here, if we really think about it, it turns out that the tension force on the person is really just a force on the person by the barrel. And likewise, the tension force on the barrel is really just a force on the barrel by a person. And I like to look at it this way. If you were having a tug of war with someone, you could use a rope to pull on each other, or you could just grab hands and you could pull on one another with your hands. If you're pulling on one another with your hands, then you can really see that that pulling force is just a force on you by the other person and on the other person by you. So ropes are just ways of 2 objects exerting a force on each other from a little bit of a greater distance. So this tension force is really just a way for the barrel to exert a force on the person and the person to exert a force on a barrel. Now, that's only true if the rope has no mass. If the rope has mass, it confuses things, or I should say makes them more complicated, but we're not going to worry about that in this video. Okay, next step. Once you have a good free body diagram, is to write the Newton's second law equation for each object. What I mean by that is acceleration equals, and I like to do blank parentheses, divided by mass. So normally in a textbook, you'll see this written as acceleration equals net force divided by mass. But what does net force mean? That sigma literally means the summation of the forces. So in these blank parentheses, I'm going to add up the forces that are in the picture. But before I do that, there is one special thing about a pulley problem we have to talk about. And that's the fact that, these 2 objects are tied together. Since they're tied together, they're going to have the same acceleration. We're assuming that the rope is a taut rope and it's not a bungee cord. If it were a bungee cord, then one could move and the other one doesn't have the same acceleration, but that's not the case here. These 2 have the same acceleration, except, the person's going to move up. So that's acceleration, in this case, in the positive direction, whereas the barrel is going to move down. So that's acceleration in the negative direction. They're supposed to have the same acceleration because they're moving together. And that positive and negative sign on either side of the pulley will mathematically mess you up. So what we do is we think about an axis, let's say the y-axis, because I'm going to draw it vertically, and usually we think of the y-axis as being vertical. Normally, you think of the y-axis as being a perfectly straight line, and usually I'm going to draw an arrow here to point in the positive direction. But a pulley, what it does is it changes the direction of motion. So imagine that the rope is your axis. In this case, I'm going to draw this axis where the rope is. So imagine the rope is your axis. It could be your x-axis, it could be your y-axis. It depends on the situation exactly. Here it makes a little bit more sense to call it the y-axis. And you'll notice that the pulley bends the rope. The pulley bends the axis. And what you want to do, look at, here's the arrow that shows the positive direction. I'm just going to draw that here because it was bent over the pulley. And if you want to remind yourself, just keep drawing arrows in that positive direction. And what this shows you is that on the right side where the barrel is, up is the positive direction. I'll write that over here as a reminder. So on the right side, up is the positive direction. But on the left side, down is the positive direction. I'll write that over here as a reminder. So that's one super important step in a pulley problem. Decide on a positive direction for how you're going to identify what's the positive direction and what's the negative direction, and be consistent with that in your axis. And in this case, flip it over the pulley like that. So maybe I'll even label the forces in my picture. The positive direction on this side is down, so that's positive. That's negative. The positive direction over here is up, so that's positive, and that's negative. Now we can do the Newton's second law equations. You might even want to pause the video and try to do the equation yourself and then start it up again and see if you got the same thing that I got. So here for the person, I would just do negative Ft and positive force of gravity on the person. And down here, I'm going to write mass of the person. If we're just doing the forces on the person, we just need to do the mass of the person. For the barrel, and again, you might want to pause, try it yourself, and then see what I did. We have positive force of tension, negative force of gravity on the barrel, and again, down here, this is the mass of the barrel. We can do one other equation for a compound body like this, and that is an equation for the combined object. So both masses put together. I'm going to put mass of person and mass of barrel here. And up here, then, I'm going to write all of the forces acting on both of the objects. Positive force of gravity on the person. Negative force of tension, that's on the person. Positive force of tension, that's on the barrel. And negative force of gravity, that's on the barrel. And here, since we discussed earlier that the tensions are actually equal and opposite, we can cross them off. And that's going to help us to solve the problem. So that's your Newton's second law equation for each object and for the combination. And so now let's just start doing some calculations. We don't have enough information to solve either one of these top equations because we have two unknowns. Acceleration is unknown and the tension force is unknown. But we can solve for acceleration with the combo equation, so let's do that. Oh, you know what? We need to find out some forces of gravity. So the force of gravity equation is just m times g. You should be real familiar with that. So the force of gravity on the person is 100 kilograms. And on Earth, there's 9.8 newtons for every kilogram. So that's 980 newtons for the person. The force of gravity on the barrel is 500 kilograms, again, times 9.8 newtons for every kilogram. And that's 4,900 newtons. Okay, so let's put that into our equation. So that means we're going to have positive 980 newtons and negative 4,900 newtons. The total mass is going to be 100 kilograms plus 500 kilograms. And so when you work that out on your calculator, you should end up with negative 6.5 meters per second squared. Actually, I'm going to round that off a little bit less, negative 6.53 meters per second squared. And take a moment and consider, why is that negative? If we look back at what we decided the positive direction would be, it was this way. This is the direction that we decided would be positive. Well, which way is this system actually moving? Well, it's actually moving that way. It's moving in the negative direction. So we probably knew that anyway because the barrel of bricks is so much more massive than the person. That just confirms that each object is going to move in the negative direction. The person moves up, the barrel moves down. Now, how about finding tension? Well, we could do that with either one of these two equations. It truly doesn't matter which equation we use to find tension. So maybe I'll use the one for the barrels, just because there's a positive tension force here, a little bit less algebra to deal with. So using this equation, just filling in the values, the acceleration is negative 6.53 that we just calculated. The tension force, we have positive Ft, that's what we're looking for. And then in this equation, we have the negative force of gravity of the barrel, which is negative 4,900. And then here we just need the mass of the barrel, which is 500. So if you punch those numbers into your calculator, you should get 1,633 newtons approximately. And if you want to check your work, you should try the exact same thing with the equation for the person, and you should find that the tension force is exactly the same, 1,633 newtons. So hopefully that was helpful, and good luck with pulley problems.